My name is Cheng Zhujiang for those people who may not know. This video is for my project on web-based circle practice system, as you have seen here. This website is basically a system for students' online circle practice. It has been deployed on the ICE server in our department. The system is developed by using C# and ASP.NET. It uses multiple backend database platforms, such as MyCircle, SQL Server, PostgreSQL, SQLite, Oracle, IBM DB2, and Access to meet the demands for students in different levels or groups. The user can practice the circle command using the online interpreter and will receive immediate results after submitting the query. Let me go ahead and show you the system very quick. Here is the homepage with two drop-down lists containing database servers and database names which are associated with the selected server platform. The user can view the database diagrams by clicking the Show Diagram button. They can create their own database to practice on. It also contains a text editor which can accept the input query, as well as a grid view to manipulate the query result. We will try to practice some circle commands later to see how it works. This is the change password page. It allows the users to change their password. I applied the required validation and the password comparison validation on it. Now the user management and the database management are for the site administrators or for the people who are kind of controlling the site. They can manage user accounts and assign the users to different groups. The group name is associated with backend databases. Different group has different databases available to operate. I used a grid view control to load and restore the account information. Also use it to implement the inserting, editing, deleting, paging, and sorting functions. For the permission management, the detailed view control demonstrates some of the clearer ways of inserting, editing, deleting records. Let's create a new account for testing. Let's create the user1 and the user ID. The password is the same as the user ID. Let's assign this user to group level 1 and user 1 has been created. Let's take a look at which database is available for this group. Access, DB2, MySQL, Oracle, SQL Server, SQLite, PostgreSQL. And the second column is the database names available in the particular server platform. Alright, let's log in with the new account. We can see only two pages available for the average users, the circle practice and the change password. We can choose different database platforms from the drop-down list. We can choose different databases under the selected server platform. We can click the button to view the diagram. Let's try to write a query for testing. If it's the first time a user practicing on the particular database, she has to create her own unique database firstly, because the connection string is designed to connect to each user's individual database. Let's create it by clicking the Create Reset Database button. Let's create all the databases. For the database creation function, I used a backup tool to backup and restore databases in MySQL. The package can be installed over NuGet. I created the PowerShell script to duplicate the access file and the SQLite database file. For PostgreSQL, I coded the command to clone and rename databases from standard system database template. For SQL Server, I created the stored procedure to restore database from backup files. And for IBM DB2 and Oracle, the system doesn't have this feature yet. This function requires the database file or backup file pre-created. Of course, the user can restore the database to its original contents at any time by clicking this button. Now we can execute the query. The results will be shown in the grid view. Let's try something on Oracle. If the input query contains some syntax error or some errors occurred during the execution, the system will display the error message instead. And the editor is designed to allow only one statement to be executed at a time. If it contains 0 or more than one statement, it will pump up the error message to prevent further execution. Let's try to execute the 2 statement. The error message will pump up. I used a regular expression to complete this. Let's log on to the ICE server to take a look at the source code. Here it is. The pattern means look for 0 or more white space or semicolons at the beginning of the string, followed by the word, followed by any character except the semicolon. Look for 0 or more semicolon or white space at the end. If the typed string matches the pattern, it will forward to server. Otherwise, it will pump up the error message. Also, the user's input can be restricted to prohibit privilege abuse. For example, we can restrict the user to execute select-only queries. Let's try to execute the delete command. Permission was denied, so the user don't have the permission to change the data. For SQL Server, there's a particular function I want to show you. I took the advantage of SQL Server's transaction controls. When the user executing non-selected DML, the system will automatically insert the output statement into the commands typed in the editor, then forward it to server for execution. The results will be shown in the grid view. The user can choose to commit or rollback the result. For example, let's try to update some records on table customer. Let's display all the details firstly. Let's update the last name of the first row, where the customer ID equals 1000. Let's execute it. The inserted record will be shown here. Also, the deleted record will be also shown in the grid view. Let's click undo. The record will be rolled back. See, the data hasn't been changed. Let's try to execute it again. This time we click the save result. The commit statement will be issued for this session. The data has been changed. Let's try to drop some tables. Let's display all the table names in this database firstly. There are five tables in this database. Let's drop transaction tables. Drop table. Save the result. Take a look at the result. 4 tables left. Transaction table has been dropped. Okay. Let's restore to its original contents by clicking the Create or Reset Database button. Execute the query again. The transaction table comes back. These are the main features of this system. All that I've been done is I want to make something that takes the knowledge and skills I have learned, such as C#, ASP.NET, HTML, JavaScript, and SQL. Also, I want to use this as my personal practice on different DBMS configuration and database implementation. Since this website requires constant access to the backend database, security is an everlasting theme. This project mainly focuses on the interaction between web application and the backend database. Cares little about the security issue. Even the real database name and objects are kind of hidden to end users, and the input can be restricted at the front end. The user can still do something damage. It is possible to work out a way to establish individual connection to the database for each user, executing stored procedure to grant proper access to the database or schema object, and to control the ability to execute system operations. This can be the future work to improve the interactivity and the security of the system. If you have any question, please do not hesitate to contact me. Thanks for watching.